Download this code from codegive.com, link in the description below. OK, let's dive into creating a robust and well-structured Python project. This tutorial will cover essential aspects of project layout, dependencies, virtual environments, testing, documentation, and more. We'll use a simple example project to illustrate the concepts. Example project, a basic calculator. For this tutorial, we'll build a very basic calculator application that can perform addition, subtraction, multiplication, and division. This will provide a concrete example to apply the principles of project structure. 1. Project directory structure. The foundation of a well-organized project is its directory structure. Here's a recommended basic structure. Let's break down each component. *my_calculator/ top level directory, the root directory for your project. *readme.md*, a crucial file that explains your project. It should include *project name and a brief description. *installation instructions. *usage examples. *license information. *contribution guidelines, if applicable. *links to documentation. *credits or acknowledgements. *badge for code coverage, build status, etc. *license *, a text file containing the license under which your project is released. Common options include MIT, Apache 2.0, GPL, etc. Choosing a license is important as it dictates how others can use and contribute to your code. You can often generate a license file from sites like https://choosealicense.com. *pyproject.toml*, this file, along with poetry.lock, if using poetry, defines the project's build system, dependencies, and other metadata. It replaces the older setup.py approach for package management. *poetry.lock*, generated by poetry, locks down the exact versions of all dependencies, including transitive dependencies, used in your project, ensuring reproducible builds across different environments. *src/*, this directory holds your project's actual source code. Using src/ is considered a best practice as it isolates your code and prevents potential naming conflicts if you install the package in the same directory as your source code. *my_calculator/ package directory, this directory, inside src/, contains the Python package for your calculator application. It's named the same as your top-level project directory, but this is not strictly required but highly recommended for consistency. *init__.py*, this file, often empty, signals to Python that the directory should be treated as a package. It can also be used to import specific modules or functions to make them directly accessible from the package. *calculator.py*, this file will contain the core calculator logic. *utils.py*, optional. This could hold any helper functions or modules that are used by your calculator, for example, input validation, custom exceptions, etc. *tests/*, this directory houses your unit tests. Good test coverage is essential for maintaining code quality and preventing regressions. *test_calculator.py* contains the actual test cases that verify the behavior of the calculator functions. *docs/*, this directory is for your project's documentation. You'll typically use a tool like Sphinx or mkdocs to generate HTML documentation from restructured text or markdown files. *.gitinerary*, a text file that specifies files and directories that Git should ignore, example virtual environment directories, build artifacts, editor temporary files. This keeps your repository clean. 2. Example code. Let's add some code to the my_calculator package. src/my_calculator/calculator.py*. test/test_calculator.py*. 3. Using virtual environments. Virtual environments are essential for isolating project dependencies. This prevents conflicts between different projects that might require different versions of the same library. Using venv, built-in. Here we are using the E4 editable installs to install the current project, which allows for changes to the project to be immediately reflected when the project is run/imported. Using poetry, recommended. Poetry is a popular dependency management and packaging tool for Python. It simplifies the process of creating and managing virtual environments, installing dependencies, and publishing your project. 1. Install poetry *. 2. Initialize poetry *. Poetry will ask you questions about your project name, version, description, authors, and dependencies. 3. Add dependencies *. D or -deb makes it a development dependency, i.e. only needed for development, testing, and not when the project is being executed as a standalone app. 4. Install dependencies *. 5. Activate the virtual environment *. Now you can use your project's dependencies. 6. PyProject.toml example, using poetry. Using pypenv *. pypenv is another popular dependency management tool that combines virtual environment creation and dependency management. It's similar to poetry in its goals. 1. Install pypenv *. 2. Create a virtual environment and install dependencies *. 4. Running tests. Using unitest, built-in. Using ptest, recommended. Ptest is a more powerful and flexible testing framework. 1. Install ptest *. Make sure ptest is installed within your virtual environment, using either pip install ptest or poetry/pypenv as shown above. 2. Run tests *. 3. Add a ptest.ini file for configuration, optional. This file can be used to configure ptest behavior. For example, *test paths specifies where ptest should look for test files. *adopts adds command line options to ptest. Here, we're using *v, verbose output. *-cov equals src/my_calculator, enable code coverage reporting for the src/my_calculator directory. *-cov report term missing, report missing code coverage in the terminal. *code coverage *. Code coverage tools measure how much of your code is executed by your tests. Aim for high coverage, example 90% or higher, to ensure that your tests are thoroughly exercising your code. E.g. the -cov flags in ptest as shown above. 5. Documentation. Clear and comprehensive documentation is crucial for making your project usable and maintainable. Common approaches include *docstrings *use docstrings, triple quoted strings, to document your functions, classes, and modules. This is what the example code above does. *sphinx *, a powerful documentation generator that creates HTML documentation from restructured text files. It can automatically extract documentation from docstrings. *mkdocs *, a simpler documentation generator that uses markdown files. It's easier to set up and use than Sphinx. Example, mkdocs. 1. Install mkdocs *. 2. Create a mkdocs project *. 3. Edit mkdocs.yml, configuration file. 4. Create markdown files, docs/index.md, docs/calculator.md. 5. Build and serve the documentation ***. This will start a local web server with your documentation. 6. .gitinary file. Create a .gitinary file at the root of your project to exclude files and directories that you don't want to commit to your Git repository. A basic .gitinary file might look like this. 7. Making your project installable. In the pyproject.toml file, the packages section needs to be defined. This tells Poetry that when building a package, it needs to search in src for a directory named my_calculator and to include it when the project is built, packaged, and installed. Also, add this section in the same file for when someone runs your CLI. In this example, running the command myCalculator from the terminal when the project is installed will run the add function in src/my_calculator/calculator.py. Key takeaways. Consistent structure. A well-defined directory structure makes your project easier to understand and maintain. Dependency management. Use virtual environments and a dependency management tool, Poetry or pypenv, to isolate project dependencies. Testing. Write comprehensive unit tests to ensure code quality. Documentation. Document your code with doc strings and generate API documentation using Sphinx or mkdocs. Version control. Use Git for version control and create a .gitinary file to exclude unnecessary files. Automation. Consider using tools like Tox or Nox to automate testing, linting, and documentation generation. This tutorial provides a solid foundation for structuring your Python projects. As your projects grow in complexity, you can refine and adapt this structure to meet your specific needs. Remember that consistency and clarity are key to creating maintainable and collaborative code bases.